In 1792, something truly terrifying unfolded in Japan. An event so violent, so sudden, that it would claim the lives of around 15,000 people, triggered not by fire or ash, but by water. A wave, generated in an instant, that at its most extreme has been estimated to reach nearly 190 meters, over 620 feet high. And what makes this even more disturbing is where it happened. Not in the open ocean, not along some exposed, storm-battered coastline, but inside the Ariake Sea, a quiet, enclosed body of water sheltered by land on almost every side. The kind of place that feels stable, predictable, and safe. But just beyond that calm surface, something was already going wrong. Rising above the modern coastline is Mount Unzen, a complex volcanic system that, in the months leading up to 1792, had begun to quietly destabilize, not through a dramatic eruption, but through something far more subtle. The mountain was weakening from within. Earthquakes had become more frequent, small at first, then persistent, each one fracturing the rock just a little more. Inside the mountain, hydrothermal fluids altered its structure, turning once solid rock into something weaker, more brittle, more prone to failure. From the outside, nothing looked catastrophic. Villages continued as normal. Fishing boats moved across the Ariake Sea. Fields were worked. Life carried on under the quiet presence of the volcano, as it had for generations. There was no towering eruption column and no lava spilling down the slopes. Nothing that signaled immediate danger. But the danger wasn't building on the surface. It was building inside the mountain. Deep within the structure of Mount Unzen, the rock had been chemically altered over time. Hot, mineral-rich fluids had moved through fractures, weakening the bonds between grains, turning solid volcanic material into something far less stable. Combine that with repeated seismic shaking, and the entire flank of the volcano had effectively been primed to fail. It was no longer a question of if, only when. Then, in a single moment, it happened. A massive section of the volcano's flank, known as the Mayuyama Dome, collapsed catastrophically. Not a slow landslip and not a series of small failures, but a sudden, complete structural collapse. An entire mountainside detached and began accelerating downhill. Millions of cubic meters of rock moved at once. At first, the mass held together, sliding as a coherent block, but almost immediately, internal stresses tore it apart. The rock fragmented violently, breaking into a chaotic mix of boulders, gravel, and fine debris. The slide transformed into a dense, churning avalanche, something closer to a flowing river of rock than a solid mass, and it was accelerating. Gravity pulled it downward, but momentum kept it moving. With every meter it travelled, it became more fluid, more chaotic, and more destructive. There was nothing to stop it, no wide valley to disperse it, no natural barrier to absorb its energy, and critically, almost no distance between the mountain and the sea. The coastline lay directly at the base of the collapsing slope, which meant that when that mass reached the water, it hit it with full force. A dense, high-speed avalanche slammed into the Ariake Sea, displacing an enormous volume of water in a fraction of a second. The ocean simply could not move out of the way fast enough. It had no time to adjust, no time to flow around the incoming debris. So instead, it was forced upward. This is the defining moment, the instant where a landslide becomes a megatsunami. Near the point of impact, the water surged vertically, forming a towering wall. In extreme modelling scenarios, this initial displacement may have reached heights approaching 190 meters, not as a smooth, uniform wave, but as a chaotic, collapsing mass of water driven upward by the sheer force of the impact. For a brief moment, the ocean didn't behave like a wave at all. It behaved like a vertical surface. Imagine standing at the shoreline and seeing the sea rise. Not roll and not crest, but rise, lifting itself into the sky as if gravity had momentarily stopped applying to it. That's the scale of energy involved in a near-field megatsunami. But that extreme height doesn't travel far. As the wave begins to move outward from the impact zone, it starts to collapse under its own weight. Gravity pulls it back down, converting vertical motion into horizontal energy. The towering wall transforms into a series of powerful, fast-moving waves radiating across the basin. And this is where the geography of the Ariake Sea becomes critical, because this isn't an open ocean, it's a confined system. Instead of dispersing freely, the energy is trapped. The shape of the sea, narrowing, enclosed, and bounded by land, causes the wave to reflect, refract, and concentrate. Energy that would normally dissipate instead bounces back toward the coastline. The wave spreads outward, crossing the basin in minutes. As it travels, it loses some height, but it gains reach. And when it encounters the shoreline, especially in areas where the coastline funnels inward, the water is forced upward again. Along the Shimabara coast, the sea behaves unnaturally. It withdraws first, not dramatically, but enough to expose sections of the seabed, enough for people to notice that something is wrong. Fish stranded where water should be, boats settling awkwardly on the mud. It's a warning, but one that few would have understood. Then the water returns, fast. What arrives isn't a single breaking wave, but a rapid, overwhelming surge. The sea rises violently, pushing inland with unstoppable force. Even after losing height from the initial 190-meter displacement, the incoming waves are still tens of meters tall, more than enough to overwhelm everything in their path. Buildings are not flooded, they are completely destroyed. Wooden homes are lifted from their foundations and torn apart instantly. Boats are thrown inland, smashing into structures or each other. The water carries debris, turning everything into projectiles. The force is not just horizontal, it's chaotic. Water surges upward, inward, around obstacles, lifting, twisting and tearing. Entire sections of the coastline are erased in minutes. Fields are stripped, roads vanish, landforms are altered permanently, and then just as suddenly, the water pulls back. The retreat is violent. Everything the wave picked up, timber, stone, soil, fragments of buildings, is dragged back toward the sea. The outgoing flow scours the land, carving channels, deepening low areas, and reshaping the terrain in its wake. But the event isn't over, because the energy is still trapped within the Ariake Sea. The waves reflect, they rebound off the opposite shoreline and travel back again. Each time they strike, they are smaller, but still dangerous, still capable of causing damage, still capable of taking lives. For survivors, the danger doesn't end with the first wave, it keeps returning. This cycle of surging and retreating continues, gradually losing energy, until the sea finally settles, but by then, the damage is already done. An estimated 15,000 people are dead, entire communities are gone, and the landscape itself has been permanently changed. What makes this event so significant isn't just the scale of destruction, it's how it happened. Most people think of tsunamis as earthquake-driven events, massive sections of the seafloor shifting, displacing water across entire ocean basins. Those waves travel thousands of kilometers, barely noticeable in deep water before rising at coastlines. But this was something else entirely. This was local, concentrated and explosive. A landslide delivered its full energy into a confined body of water in a single moment. That's what allowed the wave to reach such extreme heights, approaching 190 meters at its source in extreme scenarios. Not everywhere, not sustained, but real. A brief, localized moment where the ocean was forced far beyond its normal behavior. And that's what makes events like this so dangerous. They don't require massive tectonic shifts. They don't require warning signs visible from miles away. They just require instability, a weakened slope, a trigger, the right combination of volume, speed and confinement. And those conditions exist in more places than most people realize. Around the world there are steep volcanic islands, unstable coastal mountains, enclosed bays, places where a similar sequence of events could unfold. Most of the time, nothing happens, the slopes hold, the water remains calm, but occasionally the balance fails, and when it does, the results can be catastrophic. The 1792 disaster at Mount Unzen stands as one of the clearest examples of this kind of event. Not because it was the largest megatsunami ever recorded, but because of how it happened and how deadly it became. A collapsing mountain into a confined sea. And a wave that, for a brief moment, may have risen higher than most buildings on Earth at the time, over 620 feet into the air. It's almost impossible to visualize, but it happened. And the most unsettling part is this: it didn't come from the ocean, it came from the land. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.